Hello students, this is fourth video of assignment 7.1. Earlier we saw capacitive reactance, inductive reactance, their units, dimensional formula and expression of current with AC circuit having resistance only in first video. In second video we had current expression for capacitive circuit. In third video, we did see how to arrive at the expression of current in AC circuit, which is having only inductor. And today we will compare, in this video, we will compare the graphs of current versus time for these three circuits. So let us first start with the equations. If I consider the resistive circuit, I will not derive the equation again. I am simply writing if V is function of sine Vm sine omega t, then current in this circuit can be given as Vm by R sine omega t. Okay. Similarly, if you have capacitive circuit, means AC sources connected with capacitor only. In that case, again we consider the same source Vm sine omega t, and then what is the current equation? It is Vm by Xc or Vm by 1 by omega c. Don't forget that 1 by omega c is also denoted as Xc, and then it is Vm by Xc cos omega t. Okay, and if I consider inductive circuit, AC source connected with inductor only, then if V is Vm sine omega t, I will be Vm by XL or Vm by omega L cos omega t with negative sign. Okay, if you have forgotten this equations, you can go back to previous video and check by yourself. So now when we try to plot it, the similarity is voltage. So first let me show voltage variation with time in all the three. Voltage is same function of sine. So if this is the variation in voltage with time, this is maximum value of voltage Vm Now how current varies? To plot current, first you should determine the time when voltage reaches its peak value and zero value. So divide the graph into 4 segments, all the 3 graphs, for precision of your current representation. See, this time is t. This is half of time period t by 2. This is t by 4. This is 3t by 4, and this is t or 4t by 4, you may say. So how do I show variation of current for resistive circuit? Observe the equation. Both are function of sine. Okay, both are function of sine only. Moreover, both are having same phase omega t. The only difference is peak value of voltage is Vm, whereas peak value of current is Vm by R, slightly less. So how do I represent it? Function of sine only, so it should start from 0 only, in phase with the voltage. Both are having same phase omega t, so both will go up together, go down together. Okay, go up together, go down together. So this is the current. And how much is the maximum value? Im. How much is Im? Vm by R. So this is how we can represent the current value for resistive circuit. Now let us check next one. In case of capacitive circuit, the voltage is again same, Vm sin omega t. Current now is Vm by 1 by omega c. Again, I would like to remind you that you can write xc as 1 by omega c. Okay. So now voltage is function of sine, current is function of cos. So if voltage is starting from 0, current should start from maximum value. Voltage is changing as per omega t, current is also changing the same way. Okay, so now as we know that this factor will go up, omega c will go up and will be multiplied with Vm, I assume here that maximum value of current is more than maximum value of voltage. Not necessary that this assumption is holding true always. Okay, so I'll start showing current from somewhere here. Okay, both are function of omega t, so when voltage is maximum, current should reach 0 value. Okay, and when voltage is 0, that is here, current should reach its maximum value. And so on. So this is the Im, maximum value of current for capacitive circuit. This is the Im, and this is how current varies. Let us move to next one, third one. In inductive circuit again, we are talking about same voltage source Vm sin omega t. Current now is Vm by omega L. So peak value, amplitude is Vm divided by omega L. We'll assume that Im is less than Vm. Peak value of current is less than peak value of voltage. Again, voltage is function of omega t, current is also function of omega t, variation is as per omega t. Voltage is function of sine, current is function of cos. And I'll have to take care of negative sign also. What do you mean by negative sign? So normally cos function starts like this, but with negative cos, I'll have to draw it like this. Okay, so I will start current from somewhere here, and when voltage is maximum, current will be 0. When voltage is 0, current will reach its maximum value, and that continues. So this is the variation. This value is Im, maximum value of current, maximum value of current. So this is how you can compare these three circuits. Okay, and once again, I would like you to try out one thing by yourself. Do this exercise once again with one slight difference. Instead of taking V is equal to Vm sin omega t, take V to be Vm cos omega t, and then see what difference does it make. For the this equation, IR resistive circuit, current in resistive circuit, current in capacitive circuit, current in inductive circuit. Will the nature of these three graphs remain same or it will change? Interesting exercise to carry out, so you may try out by yourself. That is all for now. Thank you.